many times when I got stuck in a bad situation, and deep down I wished I could just cast a spell to fix everything. Or at least bend a spoon with my eyes so I wouldn't get bored. The difference between us and a physics professor is that they say, "Come on, that's nonsense," but we say, "What if it were possible?" Today, that's exactly what we're going to dive into. We want to see how academic science, with all its claims, responds when we ask it about magic. Our case today has two parts. Part one, the evidence from academia that says magic is real. Part two, the reasons mainstream science says it's fake. The first problem is that magic is not a single meaning word. We have to define what we're talking about, otherwise the discussion is pointless. In the academic world, there are three kinds of magic. Magic number one, cultural magic. This is what anthropologists love. They say magic is 100% real because it's a real social phenomenon. A set of beliefs and rituals that communities use to control anxiety and explain what they don't understand. This type of magic's real, but only as a belief system. Magic 2, cognitive magic. This belongs to psychologists. They say magical thinking is a documented pattern in our brains, the belief that thoughts can directly affect the physical world. It's a kind of cognitive bias, especially common in childhood or under stress when we crave control. This is real too, but only inside our minds. For example, I remember once walking down the street thinking, if I don't step on every other tile, something bad will happen. I skipped a few tiles, got distracted, and suddenly saw 2 cars crash. Magic number 3, experimental magic. This is the one we're really after. Can the mind actually influence physical matter? This is where the real debate begins. Let's look at the supporters of magic. These are people known as parapsychologists. The story began in the 1930s at Duke University when a man gathered volunteers and told them to roll dice and try to influence the outcome with their minds. The results were strange. At first, participants seemed to succeed, but over time they got tired and their results worsened. Researchers said, "See, this isn't cheating. They're genuinely getting fatigued." But dice rolling involves countless physical variables. So they had, okay, let's try something more advanced. That's when they turned to random number generators, or RNGs. Intrigued tone. These are devices that operate with unpredictable quantum processes, like radioactive decays. They work in a way similar to heads or tails, or electronic coin toss, that cannot be cheated. The goal was to isolate only human intention. That's when the statistics became frightening. It wasn't just 1 or 2 experiments, it was decades of research. They combined all these experiments using a statistical method called meta-analysis. A large meta-analysis in 2006 reviewed the results of 380 studies. The outcome showed a very small but statistically significant effect, meaning a consistent deviation from pure chance was observed. Slightly mysterious, they also had another interesting experiment. Another project with 2.6 million dice throws produced a result with a probability of being due to chance equal to 10 to the power of minus 70. That is a decimal point followed by 70 zeros and then a 1. Excited, but the most fascinating one was a meta-analysis that reached a significance of 7 sigma. Do you know what 7 sigma means? Sigma is the unit of verification for these types of experiments. 1 sigma means, not bad. 2 sigma means, interesting. 3 sigma means, wow, this should be investigated. 5 sigma means, it's almost reality. But in this experiment, they reached a significance of 7 sigma. Astounded. 7 sigma means the probability that the results are purely due to chance in 1 in 781 billion. Magic supporters say, look, this is a stable statistical anomaly. A very weak signal that shows consciousness and matter are somehow connected. So case closed. Magic is real, right? Now shifting to a serious and authoritative tone. Not so fast. This is when mainstream science steps in and raises a few objections. First, statistics versus statistics. Science says that 7 sigma number looks really nice, but we have something called the file draw problem or publication bias. The idea is this. Imagine 100 laboratories ran that RNG experiment. 95 of them get no result at all. What happens? Their papers don't get published. They go into the drawer. But the other 5 that, purely by chance, got a positive result do get published. With a deliberate pause and then emphasizing the key point, now when you come in and do a meta-analysis, what do you see? Only those 5 positive papers. That meta-analysis of 380 studies itself said that this pattern, small studies showing big effects while large studies get results close to chance, is a classic sign and publication bias. In other words, the whole thing could be just a statistical mirage, with a tone of finality and a bit of a dramatic flair. On top of that, these experiments are not truly replicable. The US National Academy of Sciences, after 130 years of research, said it has found no scientific justification for it. Now with a knowing, almost humorous tone, second, psychology. Science says something doesn't have to be real for us to believe in it. Our brain is wired for magical thinking, because it gives an illusion of control and reduces our anxiety. The best example comes from an anthropologist. He saw that when fishermen were fishing in a safe lagoon, they didn't use magic at all. They just caught their fish and went on with their lives. But the same people, when they wanted to go out into the deep and dangerous ocean, suddenly had 100 rituals and spells on their ships and constantly chanted incantations. Magic is there to reduce stress, not to change reality. With a definitive and firm tone. Third, physics. And this is the final blow. Physics says your claims violate the most fundamental laws of the universe. First, the law of conservation of energy. If you want to bend a spoon with your mind, you have to give it energy. Where does that energy come from? From nothing? That's a blessing, I guess, because right there you've broken the first law of thermodynamics. Second, the four fundamental forces. A physicist named Chang-Roll, Schroeder, depending on the source, basically says, we've looked, and we've only ever found four forces in the entire universe. Gravity, electromagnetism, and the strong and weak nuclear forces. Where is this force of yours? If it existed, it would either be strong enough for us to detect it in laboratories, or so weak that it's completely useless. It can't be a force that turns on only for magic, with a confident flourish. Fourth, exposure is always at the heart of a good magic trick. Remember when Uri Geller bent spoons? A magician came out and said he was just doing sleight of hand using pre-weakened spoons. Geller's most famous moment was on the Johnny Carson show. Carson and his team prepared the props themselves, meaning they replaced the weakened spoons with strong ones. The result was obvious. Geller couldn't do anything. He said, the energy in the room isn't right. Chuckling, yeah, you couldn't cheat. So are you confused yet? Great. So what's the final anchor? Is magic real? Thoughtfully again. The academic answer is both yes and no. Yes, magic exists as a powerful cultural and psychological force, a real phenomenon that shapes societies and helps us cope with anxiety and uncertainty. And no, magic does not exist as a physical force that can break the laws of physics. Cheerfully, if you enjoyed this video, tell us your thoughts. And if you have an interesting topic for the next one, leave it in the comments. And if you like this video, hit the like button. Maybe, just maybe, you'll magically see our next video too. We love you, QTV fam.